Hello everyone, this is Corbin Moss, and this is going to be the Exercise 6 Predictive Modeling with Regression. And for Exercise 6.1, it is asking us to use SAS Viya to run a simple linear regression on exam dataset with the exam mark as the target and hours of revision as the predictor. So as we can see, moving on, as we see 6.1 going to the linear regression chart, we can see the response is going to be exam mark, and the continuous effect is hours revision. And then maximizing this, we're able to see the perimeter estimates and then the dimensions, overall ANOVA. And this is going to be the most important subcategory, and that's going to be fit statistics. So as we can see, the R square is 591252, and we're going to compare that to the 540158. Moving on to exercise 6.2 is a simple linear regression. So coming over, we can see that 6.2, and we have already created sales as the response and radio as a continuous effect. And it is asking us to, what is the regression equation? So first, the regression equation would be, we're going to maximize perimeter. So the regression equation would be sales equals this 68.98 times number of ratios plus 289.97. So as we can see, it's going to ask us, if we spend 8,000 on radios advertising, what level of sales would you expect to achieve? So as we can see, the equation for 8,000 is going to be the 68.98 times 800, or 8,000, sorry, plus 289.97. And that's going to give us an overall of 550,473.97. So now it's asking, is a radio significant predictor? And due to the p-value being over or less than 0.00001, as we can see right here, the radios are a significant predictor. And then what is the adjusted R squared value? As we can see, the adjusted R squared is 3128. And when viewing this, we can see that it is lower than the regular R square, so the model is not significant. Moving on to exercise 6.3 with multiple regression. It used us to ask the same data set as advertising, but instead of one linear regression, we're going to use multiple, such as TV, radio, and press. So asking for the regression equation for the new model, we're going to use the 4.18 times the number of TVs plus 64.02 or 63.57 times the number of radios, and then we're going to use the 32.65 times the number of press. And then with all that, we're going to do negative 0.1. I'm sorry, that is for the further on, for the adjusted and with the interaction effect. So that's going to be that. And then also with that, we're going to minus the 188.136. And now it's asking to make an interaction effect. As you can see, I've already created it. So when adding this in, we're going to do the 4.22 times number of TVs, 64.01 times number of radios, 32.63 times press, negative 0.007 or 0.01, and then we're going to add the sums of those and then subtract all that by the 190.24. And then with the interaction effect significance, we can see that it is not significant. And as you can see, the change when removing the interaction effect, the R square is 64.7 and the adjusted R square is 64.31. And adding that, the R square is minimally increased by, and the adjusted R square is also minimally increased. So as we can see, the interaction effect does have some type of effect on the model, but in all, we can see that the R square with the interaction effect is not significant. Thank you.